자, welcome to class, design of composite materials. So can you, I just wonder, you can hear me well? 잘 들리나, 소리?
네, 말해주세요. 네, 잘 들립니다.
So while you are taking a class, I recommend you to mute your microphone so that we don't have any echo problems. But you can always turn on your microphone and ask questions if you want. And I also let you know that I'm recording all the classes so that after class you can review the classes anytime you wish. And I might consider uploading to YouTube, but at least I'm going to share all our class in our Google Drive, which I will announce later. But again, if you have any questions, do not hesitate, ask and share your questions. That will help us to have a better class. Well, this is of course, online class, and it's not usual form of a class, but due to a coronavirus pandemic, we don't have much choice in these days. So we will do a class using the online, mainly Zoom like this on Saturday, every Saturday at 1 p.m. And what you need to have, is, I recommend you to have a microphone and video for sure. And also, all of you need to have a cutoff chat room, a group room. I'm sure you already, most of you are already invited to this cutoff so that we can communicate at the same time as this online class. So again, you need to turn on this cutoff chat room so that we can better communicate. We can share a note, we can share some files and so on. So again, you need to have this cutoff with you, and then together with this Zoom. For example, I can see how many we are here. We have about, let's see, how many we have about 20 some numbers, and in cutoff we have a group of 24, excluding myself, and again, I would like to start communicate use cutoff. Please type in your name now. For example, okay, please enter your name now in cutoff. That will be the list of students who are participating in this class. Okay, 원기 and 정보원 and 박현민 and 서승민, 이충현, and 김동윤, 정창원, 김도형, 양혜원, 김사영, 황인성, 샤위엔, 순지밍, 샤진수, 진미장, 김형욱, 딩위단, 전맹위. Okay. So for now we have a let's see. Okay, 박대림. So again, for those who just join class, please enter your name and the in the katalog. If you didn't join this katalog, and please join the katalog again. Oops. And the 윤두표. Okay, so well, today is certainly first class, and please be sure to join this Zoom on time and 1 o'clock. We will start class 1 p.m. every Saturday. And 유영수. Okay, so again, this list will be a list of a participant, student participant, and I'm not gonna, call your name one by one, and every week when we start the class, we're gonna have this category list, which will be a participant list. Okay. Again, if you have any question during class, your question will be welcome, and do not hesitate. Okay. And also for those who are not used to this kind of online class, well, you need to get used to this kind of class. If you have any problems, just let me know. Okay. Again, Zoom can be installed in your PC, in your mobile phone, any device. So if you somehow you cannot join this class on PC, you will be welcome to join using your mobile phone, as long as you can fully understand the class through anything. That's the benefit of the online class. But at the same time, I am recording all the classes. So if you by any chance miss class, you can review using this videotape. Okay. Okay, so today, as a first class of a design of composite materials, I'm sure some of you do not have much idea about composite materials, which we will discuss today and so on. But do not worry too much about the understanding composite materials. And today, as a first class of a whole semester, I would like to review or introduction of the composite materials. Well, I'm gonna use some of the slides which I used to use to present industry to introduce what we do in our lab. But I'm sure through this slide, you can familiarize yourself with the current status of a composite material, because in our lab we are doing a lot of research together with the whole industry, covering many different kinds and also many countries. So I hope that these introductions, I'd like to review what we do in our lab, and again is hope to deliver you with some background of introductions. Okay. Still, screen is okay. Sometimes I'm not sure how my screen look like to you, so I keep asking you how it looks like. Again, if you have any problem in viewing and sound, please let me know. I just want to make sure that how I deliver well my class. So again, I would like to introduce the current application of composite materials. Again, you do not know much about the composite materials. That's no problem. I just want to introduce you what kind of application we can think of using composite materials, and how can we start to work with industry. Well, I would like to cover three aspects of the innovation of composites. First one is the materials and design and process. Well, process means it's a manufacturing process. So please keep that in mind. In design or development of composite materials, there are three aspects: materials and design and process. Okay, you can say that we understand material behavior, and we design considering all kind of physical behavior, and then we manufacture based on the design. So three aspects sounds separate, but they are quite well related. So speaking of the materials, and composite materials, of course, consist of two main different materials, and main component is the fibers. Well, we will certainly cover more about these fibers, but the carbon fibers and glass fibers are major fibers. So these fibers are impregnate in resin system. So sometimes called fiber reinforced plastic. But anyhow, material side, we have two distinct materials. One is the resin, and the other one is the fibers. Okay. now use these materials and to be applied to many different products. First, we need to have this fiber system as some form of the fabrics so that we can make structures out of these fibers, and it's better to be applied to applications. So you can think of this one as like a fabrics, and this looks like a fibers. Okay, so fabric wise, there are many different forms. You can have some stitching, you can have layered, and so on. In this case, we just have fibers only, dry fibers only, and then we somehow infuse or somehow impregnate resin, and then apply to many different applications. Many different applications. This is just major examples. First one will be a wind turbine blade. Wind turbine blade is really huge structures, and these wind turbine blades turn the wind power into electric energies, and one of the most typical renewable energy systems, and becoming very popular, very important all over the world, considering this all environmental issue. And this scale-wise, the wind turbine blade and size is getting bigger and bigger, and the just one length of one blade is about now is reach about 100 meter long. It's a huge structures, and the other application will be airplanes. While airplane and aerostructures, these are very typical application of composite materials, and has the longest history of the composite, because the aerospace structure have to be very strong, very durable, and have to be very light. That's a very important aspect of these structures. Considering all these kind of aspect, the composite material is the best in terms of, again, strong and durable, and the being light. So aerospace is the very typical applications. And other one is applied to a ship building, and also offshore deep pipe. This deep the pipe into a deep water, as deep as 3,000 meter deep, so that we can have the oil and gas. This is the very typical applications of composite for oil and gas industry. So using this big pipe, and we need to have a very light, very strong pipe, which used to be made of the metals, but metal, due to many restrictions in the manufacturing process, and due to it's a heavy weight, composite material now have replaced the metals. So this is very interesting and very one of the typical applications. And another one is and LNG. Nowadays, all big ship become green ship, and they are very light. 누가 마이크를 켜가지고 노이즈가 들어가는데. Okay. These days, the composite become very important application in ship industry, and automotive again is very important application of composite materials, mainly because it's lightweight. Composite known as a very light, mainly because the carbon fibers and glass fiber, their density is order of 1.7 or 2.5, between around little greater than 1, but mainly mostly a little less than 2. And resin is the also order of 2, so the overall density of the composite structure is a little about the 2 compared to density of the steel. Steel density is like 7.5, and aluminum is about 4. And compared to metal, the composite is really light. And in the automotive applications, light is quite, the weight is related to the energy consumptions. And so being light is very critical, especially in automotive applications. And another important application of composite in these days is the hydrogen tank, because the hydrogen vehicle become very popular and will known as to replace the existing battery-based electric cars. Anyhow, many applications to automotive. Okay, so what we do, what we have done with the industry in each category is that we, first of all, applications of materials. There are major companies all over the world, a lot, distribute all over the world, and material-wise and design also, as I said, we need to design, and we have many industry in design aspect as well, and also a manufacturing aspect. So what I like to emphasize is that understanding material behavior, understanding of the resin system, and how we, the behavior of the resin, behavior of the, such as epoxy, and as a plastic, engineering plastic, of course, and understanding of the fibers. Why fibers? Why fibers play a very important role in composite material? We need to understand the role of the fibers. And these are material behavior aspect and design. Design means that, under a certain load and certain geometry constraint, we need to design. Design means we choose the best geometry, and we choose selections of materials and mainly understanding physical behavior, especially the mechanics of materials. So design is the most important aspect of composites when you design. And manufacturing, again, as I mentioned, there are major several the process in composite materials, and we have to understand to design and apply composite material to many different industry. So in each category, we have several major companies, and as a material supplier, BASF, a German company, and Arkema, a French company, they are providing many different resin systems and thermoset and thermoplastic, which I will describe more in detail, and fibers and carbon fibers like Toray and Hyosung, and even glass, a lot of glass provider in China these days. And also as a fabrics, there are many companies. And then as applications, I just picked some company name, which we used to work with, Siona and Sinoma, and DSO is a Singapore company, and Airbus and Embraer. Embraer is the Brazilian aerospace manufacturer based on their design. Now Embraer has been merged by the Boeing. And also Petrobras is a Brazil company. It's a huge, big company for oil and gas applications and Technip. And these two major companies are one typical companies which use these big, large, long, flexible risers. They call risers, and these pipes are called risers because they rise all the oil and gas and very interesting structures. And DSME and also Plastic Omnium and Bosch and Hyundai, and these are a typical case of industry. Well, this is just a few list of companies, but you can easily find more of them in the internet. Okay, so in here I like to emphasize three aspects: understanding materials, and understanding design, and understand manufacturing. In our class, as the name indicates, we will mainly focus on the design of the composite materials. But to design a composite materials applied to many different applications, we need to understand the behavior of material. We need to understand the manufacturing aspects. Otherwise, we cannot fully design. So please understand these three aspects. Now, while we global-wise, I just indicate how these companies are located in all over the world, and Hyundai and some companies in Korea, and some companies in Europe, and Germany and France, and Boeing, especially in North America, United States, and Embraer and Petrobras is in South Africa, mainly in Brazil. Okay, so I just like to give you an idea how we work with companies all over the world. And now in Korea itself, we do have many companies covering resin supplier, fiber supplier, and free-forming and product developer and manufacturer. So as you can see, each color represents this category. And resin company, one of the most typical resin company in Korea is the Gukdo and Geunho and Kolong and SK and Lotte Chemicals. And these are a major chemical companies. In Korea, well, the chemical engineering has been one of the very strong in Korean industry. So we can find many chemical companies which can produce engineering plastic which can be applied to composite materials. And also as a carbon fiber supplier, Hyosung and Taegwang. Taegwang is the one very old company, but unfortunately they didn't continue to fiber. But Toray is a Japanese, but one of the largest company in all over the world. But they do have manufacturing facilities in Korea. So resin and carbon fibers, and you can see in location-wise where they are located in our South Korea. And also preforming and research centers, and product-wise, this is not all of them, but just to give you an idea, this is the companies which are related to composite materials. And KAI is the Korea Aerospace Industry, is the one of the very well-known companies designing and producing aerospace structures. And of course, Korean Air is the also a research company which designed wings and some very important part in aerospace, working with Airbus and Boeing. And also we have LG Houses and SK Chemical and Lotte Chemical, and as I said, and Taegwang, Toray is here, and Kumho, petrochemicals, and Hyosung, carbon fibers on the Jeonju, and GS Caltex, and KC Tech, and KCC, and Hanwha Chemical, and so on. So you can think of how they distribute. You can say left-hand side and south left-hand side, and south right-hand side, and also a Gyeonggi or Seoul region. And of course, our Hanyang University is located here. And one of the major customer will be, well, Hyundai and Kia are a automotive manufacturer which are using the composite materials. Okay, and now introducing our lab, you will be always welcome to visit our lab, and we do have several different equipment. One is the material test equipment. These are equipment which are to measure the fatigue behavior of the composite materials. And fatigue is the very one of the most important behavior of the composite. In other words, after long uses of a composite under certain circumstance, the materials and structures will degrade and losing strength and losing stiffness. And so we need to characterize them. We also established some models to predict such behavior. And some impact test using drop weight, and some the fatigue, and also some just typical UTM machines. And another one is the manufacturing facilities. The lab is has the space of 750 square meter with a very high ceiling height, and CNC machines and compression molding press. And one of the most typical machine is the winding machine, so that we can manufacture pressure vessel by winding, and some infusion process. So we hope to learn one manufacturing facilities one by one, again, to better understand, better design the composite structures. And now, very important aspect of our composite center, I mean, not just for our center, but the design simulation tools will play the most important role in design process, where we we need to understand physical behavior, but we cannot design structures every time we design. We need to use tools by understanding of the physical behavior. So in that sense, we do have three categories. One is the virtual coupon, meaning that each very small scale or coupon scale, we have a behavior, and that behavior can be simulated using a virtual coupons. So we can understand how this ply behaves as a result of the fibers and resin, also different layups, and also fabric as well. And now virtual manufacturing is the one where we can simulate manufacturing. Well, we can simulate many things. And as I said, manufacturing process is an important role, but we don't have to just do it ourselves. We can simulate manufacturing process, like a draping. Draping means that we can shape all the fabrics as we wish. So we can simulate the draping. And RTM is the resin transfer molding. So we have a big molding, and we have a dry fabric in there. And now resin will be transferred to these dry fabrics, so that resin can impregnate into fibers. So this is very typical process, resin transfer molding, and this can be also simulated. And consolidations, meaning we have a resin and fabrics, and the resin can solidify. And virtual performance means that once we have a product using all the composites, we like to simulate the behavior of the impact under the structures under impact load, and also as I said, the fatigue behavior of the structures. So understanding of these categories, like virtual coupons and virtual manufacturings and virtual performance. Now, virtual application, we can apply, we can have a tools by using those tools. We can design many structures, such as a wind turbine blade. Wind turbine blade simulate the behavior of wind turbine blade. Blade can be subject to many lots of different types of wind, which will be applied as a pressure along the lengths, and those wind turbine pressure will vary depending on the situation and depending on the rotational speed and so on. So under those load, how much this wind turbine blade will deflect according to layup structures and layup materials and so on. And using this kind of a tool, we can better optimize the layup sequence and better select the materials so that we can reduce the weight and reduce the cost. So that's the tool for design of a wind turbine blade. And construction rebar. And composite nowadays been applied to many constructions, buildings and bridges. So in those aspects, composite become very popular, and one of the typical application to construction is called rebar, replacing steel rebar, because a steel rebar can be easily corrode, and so that limit the life of these structures. And so plastic rebar or fiber reinforced plastic rebar become very popular. And pressure vessel, we can have a virtual application tool for pressure vessel to design and developing, for example, hydrogen tank we can simulate and behavior, especially to how to optimize the layup angles and how to optimize the selection of materials and considering cost and considering mass. And sheet molding compound, we can have a dry fabric, it's called sheet, and molding and compound. And this can be also simulate. We're not gonna cover all kinds of a process, but if you need, you can find more information from the internet, like what is the SMC, what is the RTM, and you can find more information from the internet. And automotive parts, you can have many, really, literally, so many parts. Just one of them will be a spring and the chassis part. Okay, so let's move on. And now we cannot cover all the application, but I like to just introduce some part, just a few example using some research we have done with the industry. And kind of a long time ago, about more than 10 years ago, this is the one most typical application of composite materials. And this is a huge rotor and called flywheel energy systems. And this is the very large. So when we have energy and we like to store the energy, these days, lithium battery is the one we can store energy into, but the one alternative way is to store energy is that we rotate this huge rotor using the motor. So this rotor will spin. And if we, this motor rotor will keep spinning, and whenever we need energy back, we can easily turn this motor into generators, and we can generate the energies. And this is one of the very interesting and very challenging tasks ever been in composite history. Now this technology has been developed and has been transferred to a company called Beacon Power, and Beacon Power is now still using this technology. And another, this is the oops. This one is the close look of the wind turbine blade. And we still have this machine, we still have a capability of winding machines. And this is the one typical demonstration of a winding process for a huge rotor. This is a mold, and this is the fibers, wet fibers, because the fiber and resin already impregnate. So wet fibers and just wound over the mold. And then we have a heaters and very long process of winding, and we put into an oven and we make the rotors. And the again, this one as used as the energy storage system and applied to transfer to a Beacon Power. Now, speaking of the Beacon Power, I just got a website. As you can see, Beacon Power, they are using this rotor to store all kinds of energies. As you can see, it says the carbon fiber flywheels, and as you can see, this is exactly what we have developed. We transfer all the technology to them, and they are using this rotor and using this rotor and store these energies and apply to a grid balancing. Means that these days the all energy has to be balanced. In other words, let's say you have a I better use they are, say, this kind of a huge huge storage plant. So each container have the many rotors like that, and so huge park where it's like a big lithium-ion battery stage. Is equivalent to a lithium-ion battery. So when you have energy, you store them as a battery, and then whenever you need a battery back, I mean energy back, you use this you can have the energy back. This is very stable and literally unlimited life. You know, a lithium battery has a limited life, but this flywheel has a no limit in the energies and beacon power. This is the container. In the container, we have 6 of these wheel inside, and this container, as you can see, we have many containers. Well, this is the one of the I didn't know, but this is the us. This is a wheel. I mean the hub. This hub is get into here. We have a hub inside. So not only this rotor, but the hub inside is the also very important. And we also developed this technology to this is the all the members of our group, and so this the well, okay, there's another picture. I didn't know we have many pictures, but these guys is from Beacon Power, and they visit us and they learn how to make for all the rotors. And these are our members at that time. Again, we are very happy to able to develop technology and the transfer to them, and they are using this one, and they have a big business. Okay, so this is the how we collaborate with the industry. We work and we and develop a very challenging task so that the industry can use our technology and they contribute to our society. So we contribute to I mean, as a result, our researchers contribute to a global society. Okay, so our next application will be we worked with Toyota a long time ago, even more than 10 years ago. These days, the composite application of composite to a automotive become very popular. But at that time, this is the first ever project in developing composite for automotive. So we are very happy to work with Toyota and develop optimize the stitching patterns of the this NCF. So this is applied to Lexus we are very proud, and this called super Lexus, only limited editions, only 500 cars. Each car cost that time about 200,000 US dollar, but easily sold all of them. And the again, that time how we stitch is called NCF, and the was a very interesting project. And also there is another different form of the composite is called braiding, and braiding is the how we braid the fibers and making some closed form like a tube, and these kind of structures, braided structure is very strong under impact, and known as one of the most strongest structures in composite structure. We work with them, and then this kind of braid applied to Gen X jet engine. This all the cage covering this engine is the very I mean, needs to be very strong. Trying to okay. Oops. As you can see, this is the called braiding, very typical structure, as I said. And this kind of braid composites are very successfully applied to a jet engine. So this is the jet engine for aerospace, and imagine how fast this jet engine blade rotating, and this, by the way, this blade is all even blade made of composites. Oops. And to protect this engine blade on fire, on burst, how they protect using this braided, say, burst protections. Well, I'll find and share later. So this braiding, the main reason why this braided structure is so strong under impact is that the way their toes interlocked between, I mean, each toes, and there are many different patterns, and these patterns makes themselves very strong. And also, composite has been applied to many structures of the aerospace and the automotive, and fatigue life become very popular, very important, and Bosch and BASF. Well, that time the wind turbine blade, they like to apply their resin system to wind turbine blade, and again this wind turbine blade has to last at least 20 years. How can they be sure about this long-term life? So we need to simulate and predict the behavior of the composites. So that's the one of the major our contributions. And for that purpose, we understand the behavior of fibers and behavior of resin and their interface between the fiber and resin. We have an interface called sizing, and all these three ingredients will play very important role. So we understand each component and layer and so on. And Acciona is also one as a wind turbine blade, and Shomarat is the as I said, this will be a plate as a fabrics. See, we have a fibers. We need to have a fabrics, and for that we need to stitch them. Now, Arkema is also a resin supplier, and we've been working with them for many different applications. And also, as I said, Technip FMC is the one developing flexible oil and gas risers, and deeper and more cost-effective. And pipe is a huge pipe, as you can see. And this is the very interesting applications, and some of the Korean companies like to enter this industry. As you can see, I hope we have a more chance to introduce this kind of structures, but briefly speaking, way down, like a 3,000 deep, you can imagine how much pressure from the outside and how much pressure inside. Inside means that this gas and oil has a huge pressure out of Earth, and then so huge pressure and a lot of heat applied to inside, and externally a lot of pressure due to a water deep. And then this has to, oil and gas has to be raised into top, and the and also this pipe and considered as a long beam has to be very flexible. So flexible, but still has to be very strong. So many different types of a form, and the computer simulation wise, we have many very complicated modeling, but this way is so complicated and lots of numerical problem. So we developed a analytical solution and approach, and developed as a design tools. And speaking of the oil and gas application, offshore applications, we not only just a flexible riser, we have many different applications, like long wires and pipes and some platforms and so on. And again, the main reason why we need to use the composite is that all kinds of corrosion-free composite never get into corrosions. And also one of the interesting application of a composite material is the bio application. This is the one of the spine, our body and spine. And spine, we have a disc. We have a disc, and this disc can be easily ruptured, and we feel a lot of pains. So, and that time, me as a patient like to develop this artificial disc, and then this design, as you can see, made of the fibers and made of the fiber reinforced nucleus as a core. So under pressure, this core is expanded and surrounded by these fibers. So it really work like real disc, and this artificial disc can at that time replaced existing metal types, and very successful. So we had a patent, we start a company, and we raised the $40 million, and at that time another 60 million, so about $100 million investment. So very successful applications. I'm very proud of these applications and contribution to our society. And as you can see, you can find more applications. I mean, you can easily type this spinal kinetics. Oops. You can type this spinal kinetics, and you can better understand how this artificial disc can be applied to spines. And this is the, how they do a surgery. And so when we develop this artificial disc, we not only develop this artificial disc, but we also need to develop the surgery process so that we can, how to open, and the, so again, it was a very interesting applications of composite materials. And the, I hope we can find another interesting. But again, you can easily find more example and more applications of artificial disc, and the even a YouTube. And this is the, as you can see, your lumbar, and this one is easily replaced, and you can measure the size of this disc, and you measure the mobilizations, and you have a many different way of measure that. Before you insert them, you need to open up, and then you again you lift up, and this is the a kind of front side. This the backyard is back is the here is the back. And this disc now is an insert from here to, is an anterior post, and anterior side means it's a front side. This is a back side, by the way. And here, so this video demonstrates how surgeons operate, how to insert this artificial disc into a real body. You can have some kind of rails so that this disc can easily plug in, and then this actually the bone will grow and fuse top and bottom. And now this one will be a very big, disc is the insert. This is a cervical and lumbar. And okay, let's move on. And another application, very typical application of the composite is the roof top. And we've been also working with the Hyundai for many different applications. Say when we develop a certain part of the automotive, we need to understand how whole structures behave. So when we replace the only roof, we need to simulate the whole structures, say twisting behavior or bending behavior. So again, when we develop the roof, we understand the behavior of whole structures, twisting and bending behavior, and the role of this roof to such a stiffness. So main issue was how we select materials, how we optimize them, how apply to a chassis and durability and cost analysis and so on. And this is the roof panels and woven fabrics and NCF and braided, which I described, and woven and NCF. So Hyundai at that time, this is the first time project and develop this kind of application and design. And very importantly, when we develop the composite parts, we need to consider the cost, how the cost will be, the part when we have mass productions. So together with the development, technical development, we need to consider the cost of composites. Otherwise, at the end of the successful development, we cannot turn into a mass production simply because of a cost. We don't want that happen. So we need to consider the cost together with technical development. So we consider the price and also apply to aerospace. Imagine how complicated it is. This is a joint between the fuselage and the wing, and this is how they are connected. And we have so complicated structures, but not just complication, but very strong and very light, and replaced with a composite. These are main some of the application I want to introduce. And okay, well, that's the one part of my class today. And let's say we have a 10-minute break, okay? So it is 2:10 right now. Let's get back to a class 2:20. 자, 지금 2시 10분이니까 10분간 휴식하고 2시 20분에 다시 시작하겠습니다. 오케이? 자, 다시 수업 시작해요. 잘 들립니까? 자, 혹시 지금 1시간 좀 넘게 수업했는데 강의의 어떤 그 뭐랄까 이 온라인의 어떤 사운드라든가 혹은 화면 공유라든가 뭔가 좀 코멘트 할 거 있나요? 아니면 뭐 다 잘 들립니까? 다 잘 들려요? 자, 여러분들이 말을 할 때는 마이크를 켜야 되고요. 그 다음에 수업 중에는 마이크를 꺼줘야 돼요. 그래야 이 여러 가지 그 뒤에 소리가 안 들립니다. 질문 있을 때는 언제든지 키고요. 여러분이 타이핑 해줬네요. 땡큐. 네, 타이핑 해줘도 좋고요. 만약에 코멘트를 이렇게 타이핑할 때 여러분들이 이 카톡방을 이용을 해도 좋겠습니다. 뭐 여러 학생들이 같이 뭐 보고 듣고 해도 전혀 문제 없는 쓰니까 뭐 프라이빗 코멘트 외에는 여기다 같이 해도 좋겠습니다. 그래서 자, 다시 요게 오늘 출석부가 되겠습니다. 네, 요 출석부가 뭐 딸리 이름 부르지 않을 거예요. 이게 이제 오늘 출석부가 되겠습니다. 오케이. 자, 세컨드 파트로 갑시다. 자, 앞서서 얘기한 여러 가지 그 어플리케이션 잠깐만 녹화되는 거 봅시다. 오케이. 어플리케이션을 이제 개발을 할 때 뭐 지금 so when we develop a composite product considering material behavior and manufacturing process, and finally we design and productions, there are some major issues we need to consider almost for all the possible composite applications. What are they? Well, in composite development, okay, we need to, as I said, we have a three quite distinct area. First one is the materials. And materials, I like to emphasize again, the composite is made of fibers and resin. Resin now have a thermoset and thermoplastic, and TS called TP. So these are materials and fabric types and material cost and processability. So when we select materials, we need to understand the behavior of the materials. And again, the fibers are mainly carbon fibers and glass fibers and aramid and so on. And resin, we have a thermoset and thermoplastic. What are the thermoset and thermoplastic? Well, the thermoset means that when we have a heat, the material will get set or hardened. And thermoplastic means that thermal means the under heat will become plastic and soften. That's the behavior of the plastic. So as a fabrics and things like that. So this is a material aspect and design based on the multi-scale. What it means by the multi-scale is that when we design, we consider not just macro aspect, we consider the microscopic behavior, considering fiber and resin behavior. And we can think of innovations, meaning we don't need to stick to a conventional layup sequence. We are free to explore a new design of the angles. And also okay. Oops, sorry. Oops. So the beauty of the composite material is that you can develop your own material by selecting your own angles, so that you can have your unique materials which nobody could have. So you can enjoy selection of the materials, and you can be a very unique designers. So you as a designer, rather than just copying others, you can have you can turn your ideas into a real application, and that process is certainly enjoyable. And then design from structure simulations. Just 1 second. Where are we? 지금 잘 보여요? Okay. Thanks for notice. Okay, so again, I like to emphasize that we can explore, we can develop our own composite materials. As I like to show my okay, I like to put these things into here. Okay, so again, I like to emphasize again, the beauty of the composite material as a designer is that you can explore your own idea. You can turn your own idea into a real product, which nobody can have. So that's how we enjoy playing with the composite materials. That makes the design process is real fun, and so we don't work, but we can enjoy working with composite materials, and especially in design process. But it's not that easy. And the well, third stage is the manufacturing process. Not just one process, but also we can play with the hybrid process and to reach the lowest cost, and meaning we can reduce the cycle time and better performance. And of course, we often need a molding tool to better impregnate resin into fibers. I mean, impregnate the fiber into so the composites. So manufacturing process, we have a compression, we have an injection, we have a RTM, we have a RIM, CRTM, and many RTM process. And one of the main issues in composite material is to automate the manufacturing process. Okay. Again, there are some a technical word. Then please go ahead and find them in the internet. So we do have these three process, and we need to, each process is very challenging, and especially for materials, the cost is high, and design process is not easy, is difficult. Even though we can enjoy design, but there's a process is at first is kind of difficult. And manufacturing process and the cycle time-wise is not short. Better to be shorter. So so we need to integrate this composite development process. How to do that? We also need to combine whole process. So we need to overcome the cost of a material. We need to overcome the difficulties in design, and we need to reduce the cycle time. So all together, we can reach the really one of the best structures in terms of performance, in terms of weight, in terms of cost, and so on. So the major player in this cycle or process is the designer. And while just specifically for automotive application, there are major issues and trend. Again, as I said, is the productivity. Productivity means that we need to optimize the process. We used to use the manual process, but which increase simply the cost of a manufacturing process. So optimize the increase productivity is one of the main issue. So for that purpose, we can have automatic tape layering and automatic fiber placement and compression molding and injection and so on. And the recyclability or eco-friendly or environment-friendly is the really important issue of the composites. And because the plastics often considered as the threatening environmental environment, and so eco-friendly, to make the composite eco-friendly or environmental friendly, we have a better choice of a thermoplastic, or we better have the choice of the recyclable fibers. And similarly, there's a TP or thermoplastic composite, carbon fiber reinforced thermoplastic. These are major issues. And how to reduce the cost? Well, we have a carbon fibers, we have a basalt fibers, and we have e-glass fibers. And we need to understand the mechanical performance of fibers, each fibers, and considering not only the material properties, but also we need to consider the cost. And so we need to reduce the cost is one of the main issues. And the selection of material, while the thermoplastic versus thermoset, and also either continuous or short fibers. That is the trend or issues in selection of, in developing composite materials for automotive industry. And this is I already reviewed. And now the composite application area and companies in Korea, I like to review again. There are many different industry area. Again, as I said, transportations, so automotive, lightweight or fuel cell, and energy area is a wind turbine blade, and also aerospace and defense area. We have fighters and stealth and missiles and all kinds of the armored car or tank, and also a ship or large container, because they need to make a green ship, environmental friendly ships. They like to introduce a lightweight composites. And also electronics and robots, the trend is to use more lighter and stronger materials for these applications. And civil and constructions and sports, where sports application is the very important of the composite as a composite application, because to reach the highest possible performance, the composite can be, considering the lightweight of composite, high performance composite, and the composite can be only choices. Okay, so there are many research and area, and I like to just select some of the cases which be considered as a successful business in Korea, okay, especially in Korea. Well, Hanguk Carbon is the company which produced the toe preg or pre-preg. They recently have a joint ventures with Israel Aerospace Institute, so that they can develop the unmanned avionic vehicles and very light, vertical takeoff and landing, and a lithium-ion polymer gasoline hybrid engine, and which can fly for 8 hours. And Kolong industry, they produce aramid fibers. Aramid fibers is very special fibers which can be applied to a bulletproof jacket, and many even applied to a flexible riser as well. So Kolong is one of the major company, and they made this aramid fiber very successfully. And the DACC, DEC Carbon, they produce carbon brake for very high-end vehicles and aerospace. They need to have a sort of a brake, but this carbon brake is one of the top end, and they are world well known suppliers. And company called Win and Win, they produce one of the best archery and using the carbon fibers and nano composites. Their market share is more than 50% all over the world. So I can select these are a very successful business. And speaking of the constructions, materials, and new applications, as I mentioned, well, the constructions company in Korea, top 10, it's a Hyundai and Samsung and Daewoo and so on. These are also considered as the worldwide construction company, and these constructions basically concrete and steel. And now it looks like a concrete can be considered as a resin, and steel wire considered as a fiber. It's very similar to composite materials. Can be considered as a large scale of composites. So concrete is okay, but steel can be replaced with carbon fibers and glass fibers, and so that's why there are huge development of new composite product applied to construction area. So bendable rebar and replacing steel rebar is a huge industry applications. And the for automotive applications, this is a lift gate, high volume and fully recycled composite lift gate. And the well, this lift gate has outer panels and inner panels. Is can be made of the thermoplastic olefin (TPO) and the long glass fibers, and the using process called sheet molding compound, and the sometimes injection and etc. And also chopped prepreg for compression molding. And this composite can be chopped like 5 centimeter long. Chopped carbons can be easily processed just using compression molding process. And this, the prepreg compression molding, just prepreg and compression molding, we can have a very complicated structures like bike, and also suspension arm, and window frame for the aerospace, and so on. And not just for one process, but also a hybrid process. Hybrid process means that, let's say we want to make a certain structure like that, and then rather than just one process, we are making a skeleton part using the carbons, and the so we make skeleton structures, and then we inject resin or short fiber, and then we make a final product. Of course, for that purpose, we need to simulate to simulate the behavioral structures and simulate how the manufacturing process. Okay, well, this is the slide we can, well, in here, what it says is there are a 12 disruptive technology, especially the era for fourth industrial revolutions. And one of them is the composite materials and 3D printings and renewable energy and energy storage system, and the mobile internet, and the automation of knowledge network, IoT, and cloud computings, and advanced robotics, and so on. So we as engineers, we need to understand the trend and how this industry goes together with our technology development. And even though we are working on one of the area, we need to understand the global trend, especially in this fourth industrial revolution. Okay, well, speaking of the cars, autonomous car, autonomous car, as you can see, we have a more interior space than new safety issue. as you can see, it's a huge inner space, because autonomous car means that you don't have to drive. The car themselves detect obstacles and drive themselves, so that the passengers, we can have more time. We can even have meetings. We can have sleep and eating and so on. So we do need more space. Okay, one last applications I like to emphasize as an introduction of composite material is the winding process. This hydrogen tank of composite, well, fuel cell vehicles is become more popular and popular, especially, I mean, nowadays, considering the current technology, the battery vehicles, full battery vehicles certainly has advantages, but also have drawbacks, such as a very long time charging period, like 2 hours, and the charging device, like a battery, lithium battery, is heavy as the 600 kilogram. And so, considering all aspects, the fuel cell vehicles is the one considered as the futuristic cars. So in this aspect, the Hyundai and the Honda and Toyota is the considered as a number 3 car makers. And in this application, we need a hydrogen gas, because the fuel cell is a simply generated energy using the hydrogen gas and oxygen. Oxygen is the one we can get from air unlimitedly, but the hydrogen gas, we need to have them, and we need a gas with a high pressure capability. So this high pressure tank have to be made of the carbon and made of composites, considering lightweight and considering safety and strong resistance. So there are very special process, winding fibers, and design process, and so on, and many different way of manufacturing pressure vessels. And for nose, we can have a 7-axis winding nose, and we can have a dry toes rather than wet winding. And so this can be a very important process. And some company tried the braiding composite to manufacture these pressure vessels. Well, they said, they announced it was a successful, but I do not know much more further story. And also another one is that is RTM process. But anyhow, the point is that they are trying to make many different efforts to reach or to reduce the cycle time, because the cycle time is the one very important process parameter to reduce the cost. So speaking of the filament wound composite for H2 hydrogen tank, a liner inside the tank is the liner is a H2 barrier. Why is called H2 barrier is that the H2, the hydrogen gas can permeate into this liner, and H2 is gradually permeate into a liner, and nobody want that kind of permeation. So selection of the liner is very important. And there are several choices, and as you can see, PA6 is the one choice, and polyethylene is a certainly choice. material, selection of materials, liner is important. And again, the H2 thermoplastic composite pressure vessels for pure cell vehicles. And this is not the wet winding process. This is the process called a thermoplastic tape. This is thermoplastic tape, and this is the wound over this liner, and this is the one we can make. This is the one process. So this is a very typical. This is a very typical a process for filament winding, and this is a fibers. Sometimes a dry fabric, sometimes just impregnate toes, and this is the winding machines. This is a toe preg, while toes is a carbon fibers, and the preg means the resin impregnate. So now these toes, the resin is already in there, and then this is just the initial stages, and this is a roller with very little frictions, and this is also a roller, as you can see, and then over the wind, the eye, and this is the mold. And now we have this is a mold, and we can have this is just an initial stage. And once we finish to set it up, we have a winding process. And once finish the winding toe, they have some shrinkage tape. so that they can hold them into compactions and during the pre-prep, the curing process. So this is the process, and once this is done, and this will be a tank, and also this is a tank. This is the one we just watch, and we have all kinds of connectors, and we have on the head we have some protectors, and this one now implement on the board on the car, as you can see here. This is the one typical. Oops. So this is a tank. We need more than 2 tank. I mean, 1 tank. It is 1 tank and 2 tank, and sometimes we have a 3 tank. And so this is the how we manufacture the hydrogen tank, and the will be very popular. So this is the one. And the okay, so one thing I like to emphasize is that in 700 bar tank, this is a very typical value for hydrogen tank. And this is the cost analysis, means that carbon fiber has the very high portion of the cost, mostly 60% of the whole cost. So you can see how important it is to understand the role of the carbon fibers. And the that's the what I like to introduce introduction of composite materials. And now I like to so okay, now I like to have some I mean any questions from you, any feedbacks, or you can say you can exchange some you know chattings. Any questions? Okay, well, now I like to cover a little bit of a main course. Say, I'm sure you already have some coursework lecture notes and in PowerPoint. So I already distribute this slide, and which we will cover in this course. And we also like to develop a certain types of simple design tools, and we will review some design tools as well, which are developed ourselves. And so in this class, I like to I'd like to make some announcement in this course. I'd like to first okay, well, I can just type in right here. Oops. So as you know, we class is at 1 p.m. every Saturday. We're gonna keep using online class until some announcement. If there is no announcement, we will use the online class using Zoom, I mean, as in today. So second, we will have a homework every week. And so which will be due next week. And third, of course, you need to be present at I mean at classes. And so you need to have a Zoom and plus Kakao Talk all the time, and there will be some Google Drive file sharing, and that is the important. So you take a participate in class, okay? You take in class, and you need to do a homework every week, and you always need to use the Zoom and Kakao Talk and file sharing using the Google Drive. And please, if you're not familiar with any issues, you need to ask me, and you need to ask your colleague, your friends. And especially the homework, okay, this is the homework. It's very importantly should be done by yourself. Okay, I'm talking about the homework. And also, you need to teach yourself how to use the Excel. Microsoft Excel is the one you need to keep using. So very important. And of course, you need to use the PowerPoint. All the homeworks will be based on the, I mean, you use the PowerPoint, or you can, of course, use the handwriting. Handwriting means that you just can use just empty. You can use just empty papers. You can write down, and you can make a photocopy, and you can copy into a PowerPoint. If you want to save your time, that's no problem. But as long as they are readable, they are I mean, understandable and clean enough, no problem. Handwritings on papers and photocopies and put it into a PowerPoint is no problems. And also, again, you need to keep using the Excel. And we will cover several different types of design tools. Most of them are based on the Excel. Well, they could have been based on the MATLAB or other high-level languages, but the more importantly, understanding the behavior is the critical one, and you can choose any development method. But I happen to choose Excel. So these are some very important announcements. Today is the September 5th and 2020. Okay, so let's do a little more deep into understanding the composites. Okay. Okay. So I'm gonna just use like that. So structure of composite or composite structures. Composite materials are, as he said, widely used in aerospace structures and passenger airplane and cars and sporting goods, which we already went through previously. And the use of aramid fiber, reinforced plastic, and carbon fiber, and hybrid fibers, and all kinds of fiber. So basically, the point here is that important point is the fibers plus the resin. Okay, fibers and the resin. These are the most important ingredients. So the fiber can have many different types. Fibers can be short, fibers can be long, and so we have many different fiber, not just material, but the fiber, the forms. So that is the one thing we need to understand. And there are following types of a composite. Well, this is just a small the example. Okay, this is not the everything, but this is just some of the applications. And the as you can see, A is the pretty much some particles, and B is the some chopped strand, and C is the unidirectional fiber. Unidirection means the all the fibers in the arranged the one directions, and the D is the fabrics reinforced. I'm sorry. D is the C and D is the laminate. Laminate means that you have a laminate of the UD, and the that's the cases, especially for aerospace structures. And some F is the one case that we have a sandwich between the skin laminate. We have a core. The role of a core is to make a little bit of structure apart and the skin apart, so that we can increase the skin distance, so that we can increase the bending rigidity. And the so depending on the in the aerospace, depending on the applications, and we do have several different types. And again, the most typical one is the type D or type B, laminate or sandwich structures. Okay, so the fiber volume fraction is very important key parameters. By the way, this slide is taken from Composite Igor Kokchatov, is I guess a Russian guy. It's not just because this slide is super, but this is just good enough slide I taken from internet. So the fiber volume fraction can be very important parameters in composites, and the fiber volume fraction means how much fibers within composites. Okay, how much composite within how much fibers within composite. And that is the very important parameters. And usually, well, it's a little different figures. I don't like this figure, but the over here, this is a fiber content or fiber volume fraction. If we increase the fiber content, the usually the stiffness is increasing along with fiber increase. And now imagine there are some broken fibers. Okay, there are some broken fibers. What will happen? Well, let's say the fibers is broken and surrounded by the resin. The broken fibers certainly cannot take over the load. In that case, the resin surrounding that broken fiber will transfer the load to adjacent fibers. So the point here is that even though some fibers are broken, and global wise, we don't have a much problem because all the load will be carried by the adjacent fibers. So there is not much problem. So that's the one of the main reasons why we prefer to use the fibers. So the fibers, billions of fibers make these structures strong and more durable. And notched composite is that when we connect the composite in aerospace, other applications, we need to make a hole, laminate. We better need to minimize the number of holes, but in often case, we cannot avoid them. So understanding the behavior of the effect of the hole in the composites is important. And stress will be certainly concentrate, and the stress concentration factor will reach some value like a 3 or 4, depending on the layup sequence and depending on the geometry. So, and also very interesting, very important behavior of a composite is the compression behavior. And the composite under compression, the behavior will be very complicated and relatively weak compared to a tension behavior. So this, as you can see, under compression, fiber can easily buckle, fiber can be bent, and layer can be delaminate, and very complicate broken behavior. So we better need to minimize the situations of the compressions. But again, we often are facing the case. And also honeycomb is composite structures can debond from a core. This is the one important issue. And I just want to go through some major, this is not all, but I just like to give you an idea how kind of real problem in composite structures. And residual stress means that when we manufacture the composite, the fibers and resin, they have a different thermal process, so that the cracks and damages can be very different depending on the material property of the resin and the fibers. So residual stress different because of a different thermal expansion. We have a thermal residual stresses. Now this one is the very important slide to helping us to understand the fiber behavior. Say we have many different types of fibers. Say boron and carbon. Sorry, it has to be carbon, and Kevlar is aramid fiber, and e-glass, and has its own strain and stress curve. Of course, the stronger the better, but the also strain failure is also important. Well, this value is a little bit, it's not so accurate, but like to emphasize how important it is, the stress and strain. We will get to more correct slide later. And now fibers, because of a short fiber, because of a broken fibers, in shear stress between the fibers and resins are important. Okay, this is the fibers and this is a resin, and there is some shear load. This can be an important role. And rigidity means that fiber directional property is much stronger than matrix directional properties. So we can have many different types of a stress strain curve, and the deformability compatibility we need to understand. We will cover more in detail, but deformability is the important because all the fibers and resin are deforming together. That understanding, that is the important. And deformation compatibility is one called a Poisson's ratio. Let's say we have certain materials, and under tension, there is a contraction in the transverse directions, and each ply with a certain angle has to deform together. Okay, has to deform together is called deformation compatibility. Understanding that is the very very important rules. I like to just 1 second, please. Before we going into detail of the mechanics and design of a composite, I like to emphasize again, well, this is just, well, why carbon composite is so important and for transportations. Well, transportation is certainly a tool, equipment for mobility, and mobility is the we have a mass. Mass can be a passengers and has a certain distance. We want to move, travel. So always they relate to a mass times energy and distance, which is nothing but the energy. So mobility is the representing energy in terms of physical behavior. So to reduce the energy, we need to reduce the mass, right? We need reduce the energy, we need to reduce the mass. Energy is the relate also CO2 emissions. So we to reduce the CO2 emission and increase the fuel efficiency and the recycling, while we don't want to limit our distance, but the way we can reduce the energy is to reduce the mass. So you can see how important it is being light. So how can we reduce the mass in automotive? Well, mass is simply density times the volume, right? Mass is simply density times the volume. So to reduce the mass, there are several choices. Number one, well, we can use the lighter material. Lighter material is the low density. That blue one is certainly a way to reduce the mass. And less volume is a certainly way to reduce the mass. So we use the less materials and less volume through a design. While to reduce the mass, we can also use the stronger materials, and so that we can overly reduce the volume. So that's why we use the carbon fiber. Carbon fiber, we have a low density, we have a very strong, now we can reduce the a volume through a design. Well, speaking of the being light, let's consider many different fibers. So e-glass, there are many different types of glass. E-glass and R-glass and S-glass, and even carbon fiber. Now, by comparison, we have a steel. And look at these values. While E-glass has the density of the 2.5, many different glass, but average-wise, the density is about 2.5. That's a good number we need to remember. And carbon, the density is about 1.7, and steel, 7.5. Very heavy, about the 5 times. Now Young's modulus, this is the fiber. Young's modulus wise, the E glass is about 70, and R glass is 80, 85, and S glass is reach 90, and carbon fiber is like 220 gigapascal. Now steel, as a reference, is about 200 gigapascal. These are numbers we need to remember. We need to understand. Okay. Again, please memorize these all the values. Now, pristine strength means the strength of a pure the fibers with no damage. So this E glass can be as high as the 3,000 megapascal, and R glass is about 4,000, and S glass even higher than other glass is like 4,500, 4,500, 4,800, and carbon even this is the very high 5,000. Now still have in terms of a megapascal about the 3,000. And failure strain is important, and carbon failure strain is about 1.5, 1.7%, and still, like in the plastic behavior, the yield strength limit is like 1.5%, and the glass is the higher failure strain, okay, higher failure strain. So as you can see, strength-wise, okay, strength-wise, the glass are as good as a carbon, but the stiffness-wise, the glass is much weaker than carbon fibers. Okay, so the self-weight tip deflection, considering E glass equal 1, the other materials has a much less deflection, and material cost-wise, this is important. And the carbon is, say, 10 times higher than E glass. Okay, 10 times higher than E glass. Very, very expensive. So anyhow, the point here is the material is very light. Okay, very light compared to steel. So back to here, to make this mass, why reduce mass? Well, reducing mass is to save energy. So to save, to reduce mass, we need to use the light light density. Now, next one is the how to reduce, how to use less material. Well, this is the most important behavior. I mean, the characteristics we need to understand in design of composites. Okay, please pay attention. This is very important. Let's say we have vehicles, and this vehicle has a roof, and this one is a subject to a load 1 and load 2, and they happen to have a different magnitude. Say this load 1 is the, for example, 3 times higher than load 2. Then if the isotropic or metal, while the thickness is just uniform, and design-wise, we don't have much choice. We, designer, has only one choice of choosing the thickness, right? Only designer can choose or change the thickness. In that way, it is very inefficient in supporting multi-axial load, because since this thickness is uniform, then we cannot optimally choose the thickness to support higher load in this direction. But in composite, where we use the fiber orientation, we can arrange fiber direction so that we can optimize the way we carry the load. So fiber directional, fibers can take a more load. So we align the fiber more toward a higher load direction. So not only thickness, but also we can play with fiber angles so that we can better support the load, so that eventually we can minimize the thickness. Okay, so in short, we can say using the anisotropy, we can better align the fibers effectively to support the load. So eventually we can reduce the thickness. Eventually we can use the less material. So eventually we can use the less material. So if we use the composite materials, this is the way we can reduce the amount of materials. Now, the last one, very fundamental question we need to understand: why fibers? Why fiber types? Why not just all carbon? Well, fiber, the form of fiber understanding is very important. Why so thin, very small fiber? This is the questions we need to understand. We need to be able to answer. Carbon fibers are strong and light, but fibers, why fibers rather than thick, bulky shape? Well, imagine these fibers is very big, very bulky, very volume, big size. Then the problem would be if there is a crack there, the crack can easily propagate, easily the structures can collapse, or catastrophic failure can happen. So bulky type structure is not good choice. Again, the reason is the crack can easily propagate. So that's why the very small carbon fiber, very small diameter, if there is the crack there, the crack will just stop and exist only that fiber, that location. So this is very important. So crack of each fiber can be localized. Fibers can conform to geometry, and resin can hold the fibers together. So as I explained, once we have a crack there, this fiber can take no longer load, but it's okay because this diameter, the size is very small, and all the load will be transmitted by the adjacent fibers and through a resin system. That's the role of the resin. So if there is a crack, no problem. The crack will stop there, and the other fibers will take over the most of the load. Now here, resin, the role of the resin plays very important roles. Resin hold the fibers together, and resin take over the load from one fiber to the others. Okay, so understanding the role of the resin is as important as the understanding of the fibers. Okay. So again, resin in composite, role and significance is as I explained, once the fiber is broken, the adjacent fibers will take up the load through a load by the resin system, and interface is very important between the fibers and resin systems. And so this is the fibers. Okay, this is the fiber, carbon fiber. You can see how small it is compared to this is the real hair. Your hair, one of your hair, and the human hair. And this is the size of carbon fiber, 7 micrometers. So theoretically, the smaller fiber and the less chance of the crack propagation. That's why the fibers, they prefer to get a smaller and smaller. And the 3K means 3,000 fibers and 10,000 fibers. And this is how they distinguish the toes. And using that, you can make very different fabrics and draping. You make a shape and you have a resin transfer and you make a structure as you wish. Okay, so this is the very important slide I like to emphasize to understand fundamental understanding of the composites. So I like to insert here, and then I like to update. This is the a class note, and then I like to please keep the version numbers. This is the version 17. So after each class, we will have a higher versions. Okay, now we have a version 17. Okay, so next one is the rear the sections, and we will briefly cover. I'm not briefly, step by step, and introduction, which we already cover, and understanding stiffness and OBXs, and the laminate, and strengths, and thermal stress, and design, and micromechanics. After that, we will go through several design tools, and we understand how we design using the rear tools, and that's how we gonna cover the whole structures. And again, this is the one we already cover. This is the chopped fiber, long fiber, and laminate composites. And composite, again, is considered to be a combination of materials and mainly fibers and resin system. And the unidirectional tape, unidirectional fiber, this is just one direction long fiber. And this is the continuous random. And this is the fabrics and woven and also braided, can be a very different forms. And again, as I briefly introduced, this is the glass fiber, and this is the carbon fibers. And very microscopically, this is the carbon fiber, and this is the very thin layer, and each layer has the carbon bond, and each one is very strong. So layer by layer. And whereas the glass fiber is isotropic, along with glass direction, fiber direction and transfers. So glass itself isotropic, but carbon fiber itself is the anisotropic as well. So carbon fiber is strong in fiber direction, but transverse direction is relatively weak. If you, that's understandable if you look at the fiber structures. So this is the little different, the values, but the values is not unique one, depending on the manufacturer and this so on, but as you can see, overall the carbon fiber density, gamma is a density. Okay, so diameter is a 7, and the is about the 1.7 versus 2.5. That's the one you need to remember. And the carbon is about the 220 gigapascal, and this is about the 70, and this is the as you can see, transverse wise is very weak. Well, this is the wrong value. This is the I have to update. So glass fiber and the this is the fiber direction, fiber directions, and transverse direction is the same because it's isotropic. But the carbon fiber, they are very different. Okay, so here, matrix has many different types. As a typical one is the polymer, thermoset, and thermoplastic. While thermoset is the one we thermoset is the one the material get hard, and we need to understand the behavior, fundamental behavior of the thermoplastic and thermoset. We will cover next week, but it is the important. Okay, and this is the one I just explained, the Y fiber type. And then with the fibers and crack can be stopped very easily. And this is, again, the material properties. And as I mentioned, I like to cover more story about these plastics, thermoplastic versus the thermoset, which is very important, especially for manufacturing process and especially for design process. This is the important point. So I like to cover this aspect next class. Okay, so and then we will go on the mechanics. Okay, so that's the one I would like to cover today. And this is again the online class. It's not the maybe inconvenient, but if you are familiar with this process, this online class is not so bad. You know, you can sit any place, you can take a course and the way you like to be. And also we can cover many subjects. You can directly use the internet. You can directly use the many references, and we can easily share the screen. So in that sense, the online class can be better than in class. Anyhow, thank you so much. And that's the one I'd like to cover today. And if you have any questions, and as I said, please share your comment. Okay, do not hesitate. Share your comments and using the talks, and it is much convenient and quicker way to communicate. Okay, so that's it. Thank you so much. I will give you just a small amount of homework that will be due next week. Next week means by the Friday night. Okay, so thank you. And any questions if you have? Oops. Okay, if not, thank you, and see you next week. Bye.